This is a problem from your lab assignment, section 5.2. It says use the midpoint rule with a given n to approximate the integral. So we have the integral from 2 to 10 of this function, the square root of x cubed plus 6 dx, where we want to break this up to n different partitions. So m sub 4 is the notation that we use for the midpoint approximation with 4 rectangles. And what we want to do is we want to essentially add up 4 rectangles. The base is going to be delta x. We'll figure out the base in a minute. And the heights are going to be the function evaluated at the middle of that subinterval that we have, where x sub 1 bar, x sub 2 bar, x sub 3 bar, and x sub 4 bar represent the midpoints of the 4 equal subintervals from 0 to 10. So let me just go to this graph here. This graph has some information. I want to adjust my x-axis to go from maybe -1 to 10, 11, 12, 13. Let's go to 13. But if we take steps of 2, we can kind of see how this is broken up. From 2 to 10, we take steps of 2. So it'll be 2, 4, 6, 8, and 10. So these intervals are the intervals that we're looking at. Okay, so if we look at the widths of these intervals, the width's going to be 2. So another way to figure that out is that there's 4 rectangles, so we subtract 10 minus 2, we get 8. 8 divided by 4 is going to be 2. And that's the formula way to compute the delta x. So now that we have that, we want to look at the midpoint for each of these things. The first interval goes from 2 to 4, and the second interval goes from 4 to 6, etc. So the middle of the numbers between 2 and 4 is going to be 3. And in the middle between 4 and 6 is going to be 5. So those are going to be the values that we're looking at. We can start with 3 and just take steps of 2. So 3 plus 2 is 5, plus 2 is 7, plus 2 is 9. So those are the numbers that we're going to put into the original function to get the heights. So therefore, we need to figure out the heights. So on the first one, if we put the value of 3 in there into the function, and our interval goes from 2 to 4, this is our first rectangle that hits the graph at the midpoint. And so this is the midpoint right here. Now we can continue on. I'll copy this 4 times, so I have 4 copies of it. And then, so the next function that we're going to put in is, the next point that we're going to put into the function is 5. And then that one has an interval from 4 to 6. And then we're going to put in the value of 7. And that value of 7 goes from 6 to 8. And then we're going to put in, finally, we're going to put in the value of 9 into the function. And that interval goes from 8 to 10. So this is our approximation. And let's go ahead and do our computation here. So we put in the values of 3, of 5, of 7, and of 9. And then we want to round this off. So we have these values here. We can essentially add them all up and then multiply it by 2. They want to round off to 4 decimal places though, and this thing only goes up to 3 decimal places. So Let's rely on Wolfram Alpha for this. So you can use calculators, computers, or even an Excel file would do. So there's a 2 outside for our base, and then these things are going to be the heights of the functions. So it's going to be the square root of inside of the square root is 3 squared or 3 cubed plus 6, close the square root, and I'm going to add a bunch of these. So I'm just going to copy and paste 4 of these, and then change the values. For the second term, I have a 5. For the third term, I have a 7, and for the last term, I have a 9. And so it looks like my result is 125.9650, and then there's a 2 there, but that doesn't change the value. So let's go ahead and type that in. Okay, so hopefully that helps. Hopefully the picture of the graph also helps, and good luck.